Good morning, algebra kids. I wish I could be there in person with you today, but unfortunately, I'm home again. Hopefully, I'll be back in class tomorrow, and so we will be able to review everything we've learned this week through videos. But for today, we're on a video again. I do very quickly want to start by going over what you learned yesterday. Since I didn't make my own video yesterday because I just wasn't feeling up to it, you watched that little generic YouTube video, which I'm sure was fine, but I want to make sure that you really understood it. So I'm just going to do 2 examples on what you learned yesterday, just to make sure you got it. Luckily, our topic from yesterday was basically distributing. Did you all realize that? The lesson was called multiplying a monomial by a polynomial, which sounds all confusing and all proper. But what you were really doing was distributing. You just had to remember the rules for exponents that we've learned these last few weeks and do more like longer and more elaborate problems than what we're used to with distributing. So let's do a couple of problems. We'll just make sure that you guys got this down, okay? Here's my first example, and I do want you to write it down. If I've got something up here, I want you to write it on paper. So get a piece of paper out, get ready to write this down. We are going to distribute what's on the outside of parentheses to the terms that are on the inside of parentheses. That allows us to get rid of the parentheses. That's the whole point of distributing. Distributing is a way of rewriting something without the parentheses. So we're going to take 5y squared and distribute it. We're going to pass it out. We're going to give it to the 3y. And before I write down the answer of what 5y squared times 3y is, I'm just going to write it out because it's hard for me to hold numbers in my head. So I'm just going to write down 5y squared times 3y. And I'll come back to that and get an answer in a second. Now I'm going to write down the minus sign, and I'm going to distribute the 5y squared to the 4. I'm going to write down 5y squared times 4. I just wanted you to see what this looks like written as the multiplication problem. Normally when we distribute, we just go ahead and multiply in our heads. I wanted to write this out though because these problems are more elaborate than what we're used to in distributing. Let's find out what the actual answer is. 5y squared times 3y. This is just like problems we've had the last 2 weeks with our rules of exponents. We multiply the numbers, the coefficients. 5 times 3 is 15. Then we multiply the variables. Write down the y and add the exponents. Remember, when you multiply variables, you add their exponents. 2 plus an invisible 1 is 3. So this first term is 15, y to the 3rd power. Now write down the minus sign, and let's simplify this term. 5y squared times 4. 5 times 4 is 20. And there's nothing to multiply variables by, so just write down y squared. Now, if you can do all of this in your head and you are getting the right answers, then that's great. Go ahead and do it in your heads. But here's a pro tip from me to you. If you find that you're doing these problems and you're not getting the right answers, then you need to show this step right here. Write down what the multiply problems are after you distribute, instead of just trying to multiply it out in your head. It might help. Let's do one more problem like this. Let's do a longer one, and then we'll get into our actual topic for today. Let's see. Oh, here's a good one. Let's distribute 5m times 3m to the 3rd power minus m squared plus 8. All right, let's distribute that. So we're going to take the 5m and multiply it by each one of these terms. And again, if you can multiply in your head, that's fantastic. If you can't, then write something down. Let me show you what to write down. We're going to take the 5m and we're going to distribute it to this first term. So I'm going to try to multiply 5m times 3m to the third power. If you can do it in your head, great. If not, write it down. And I'm looking on my screen and seeing that this red color maybe isn't dark enough. So I'm just going to switch back to blue. All right, multiply 5 times 3 to get 15. And then multiply the m's. We have to multiply m times m to the third power. Write down the m. And how do you multiply variables? What do you do to their exponents? You add them. That is correct. You add the invisible 1 plus 3 makes 4. Basically, you have 1 m here. You have 3 m's there. Put them together, you have 4 m's. So this is my first term. Now, write down this minus sign. And we're going to distribute to the second term. We're going to give 5m to the m squared. So take 5m times m squared. Let's see. 5 times an invisible 1 is just 5. M times m squared is m to the third power. You add their exponents. Invisible 1 plus 2 is 3. Now, the last bit is to take this 5m and give it to the plus 8. So I'm going to write down the plus sign. And I'm going to multiply 5m times 8. Let's see. Multiply the numbers. 5 times 8 is 40. There's nothing to multiply the variables by, the m, so just write it down. This is my final answer. 15m to the fourth power minus 5m to the third power plus 40m. So this is what you all did yesterday. Hopefully, between yesterday and between these two examples, hopefully we've got that down pretty well because we do have some background in distributing. So let's go on to our new topic for today. We do have a new topic to learn today, but guess what? It is a new, old topic. This is going to bring back fond memories from long ago. Today's topic is greatest common factor. I hope that sounds familiar. Greatest common factor. What a blast from the past. The greatest common factor is something that you learn when you're learning fractions. You learned it in elementary school. We did it in Math 3 last year. So I know you did it in 6th grade. You've seen it before. Greatest common factor is when you find the biggest number that two numbers can be divided by. For example, if I asked you for the greatest common factor, the GCF of 20 and 44, I want the greatest common factor of 20 and 44. When I ask you that question, I'm asking you, what is the biggest number that you can divide 20 and 44 by? You might not be sure. So let's just pick a number. Is there a number you could divide 20 and 44 by? They're both even, so how about 2? 2 might be the answer. Let's see if we can think of a bigger number that you could divide 20 and 44 by. Can you all think of one? How about 4? You can divide 20 and 44 both by 4. So that might be the greatest common factor. Can you think of a bigger number that you could divide both of those by? I don't think so, because 44 is 4 times 11. And you can't divide 20 by 11. So I think the greatest common factor in this problem is just 4. Does this look familiar to everybody? I hope so. Let's do one more example of greatest common factor with numbers. The greatest common factor of 36 and 48. We are going to find the greatest common factor of 36 and 48. You need to think of what can you divide these numbers by, and then find the biggest one they have in common. There are different ways you could do this. You could make factor trees. You could just guess like I did in the last problem until you get what you think is the right answer. Or you could make a list of factors. Just start listing. What can you divide 36 by? I can divide it by 2, 3, 4. I can't divide it by 5. I can divide it by 6. 7 doesn't work. 8 doesn't work. I can divide it by 9. 3 times 12 makes 36. 2 times 18 makes 36. Oh, and 1 and 36. So this is my list for things I can divide 36 by. Let's check all of these numbers for 48. Let's start with the biggest one. Can I divide 48 by 36? No. Can I divide 48 by 18? No, I don't think so. Can I divide 48 by 12? Yes, I can. 48 is 4 times 12. That's going to be the greatest common factor of 36 and 48. The greatest common factor is 12. They have other common factors. You could divide them both by 4 and by 6 and by 2 and by 3, but the biggest one is 12. Now that we've reviewed what we've learned in the past about greatest common factor, we're going to apply this to algebra. We're going to learn how to find the greatest common factor of two terms that involve variables. So let's see here. Here's our first example. We're going to find the greatest common factor of these two terms, 12x squared and 30x. We are going to find the greatest common factor of these two terms. So now, our problems are a little harder than they were back in past math classes. Our problems today are going to involve variables. To find the greatest common factor of these two terms, first we find the greatest common factor of just the numbers. This is the number 12. This is the number 30. Let's find the greatest common factor of those things. For 12, I could divide 12 by 12. Can I divide 30 by 12? No. I could divide 12 by 6. Can I divide 30 by 6? Yes. I think 6 is the greatest common factor of 12 and 30. You can also divide them both by 3, but 6 is bigger. So that is the greatest common factor of the numbers. Now, for the variables, we have to find the greatest common factor of x squared and x. That sounds really hard, but it's not. Here's how to do that. It's really, really easy. You take what variables they have in common. This is x squared, which means x times x. Everybody with me so far? This is just an x. We're going to write down the variables they have in common. They have one x in common, so write it down. Do they have another x in common? No. This one has one x, this one has two x's. They have one x in common. So put an x with the answer, and that's it. The greatest common factor of 12x squared and 30x is 6x. Basically, you take the variable that has the smaller exponent and write it down with your answer. Let's do another example. I want us to find the greatest common factor of the terms in this polynomial. These are the type of problems you're going to see in your workbook today. They're going to give you a polynomial, and they're going to say, find the greatest common factor of the terms in the polynomial. This is 18x to the 4th power plus 24x to the 3rd power minus 12x squared. So let's find the greatest common factor of these three terms. First of all, ignore the signs. When you're finding greatest common factor, you don't use negative numbers. So you can ignore these plus and minus signs. They're not important. You're just looking at the three terms. Ignore the plus and minus signs. Now, let's do the numbers. We need to find the greatest common factor of 18, 24, and 12. What is the biggest number I can divide all three by? Well, geez Louise, let's see. I can divide 24 by 12. Can I divide 18 by 12? Nope, that's not going to work. I think if we think this out, the greatest common factor between these three terms should be 6. And you guys can think about it. You can list out all the factors of these three numbers and find the biggest one, but I'm pretty sure it's 6. So I'm going to cut to the chase and say the greatest common factor of these three numbers is 6. 6 is the biggest number you can divide those three things by. Now let's do the variables. The shortcut for doing the variables is to write down the variable with the smallest exponent. This is x to the 4th power, x to the 3rd power, x squared. That has the smallest exponent, so that goes in your answer. That's the shortcut, but let me explain why it's x squared. Greatest common factor means it's something that all three terms have in common. So you're looking for how many x's do these three things have in common. This has 4 x's. X, 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 x. This has 3 x's. And this has 2 x's. How many x's do the three of those things have in common? They each have 2 x's in common. That's why it's x squared. That's why you write down the variable with the smallest exponent. Let's do one more example, and then you will have some to do on your own. Last one. Let's see. Negative 4w cubed plus 10w squared minus 8w. We are going to find the greatest common factor of these three terms in this polynomial. First of all, ignore the plus and minus and negative signs. When you talk about greatest common factor, you talk about positive numbers. So you can ignore that negative sign for right now. Don't let it scare you. You can't scare me, negative sign. Now, let's look at the numbers. Looking at the three numbers, 4, 10, and 8. What is the biggest number I can divide all three of those by? I think it's going to be 2. If it was just 4 and 8, then it would be 4. But I can't divide 10 by 4 evenly. So it's got to be 2, right? 2 is the greatest common factor of 4, 10, and 8. Now, supposedly this is the hard part, but it's actually really easy. We're going to find the greatest common factor of these variables. What do the variables have in common? This has 3 w's. This has 2 W's. This has 1 W. They all have 1 W in common. Each of these terms has 1 W. You take the variable that has the smallest exponent. That has an invisible 1 as the exponent. So you write that variable in your answer. The answer is 2W. So this is how to do greatest common factor when there are variables involved. I need you to practice this skill today because tomorrow we're going to use this new skill of finding greatest common factor to do something called factoring, which is one of my favorite things in algebra, and you're going to love it too. You now are going to do some problems in your workbook. Let's see, we're on the same page as yesterday, page 227. You're going to do numbers 16 through 30. You're going to find the greatest common factor of all the terms in the polynomials. If your substitute allows you, you can work with a partner or in a small group as long as you behave yourselves and actually do your work. Evan Kapler and Jackson, make sure you're actually working. Or if the substitute prefers, you all can work by yourselves quietly so that you don't get in trouble. That's okay too. If you guys behave yourselves in class today, then there will not be homework tonight. If you don't, then the substitute is going to text me and I will post homework to Google Classroom. So behave yourselves and do the work you're supposed to do and do a good job on it. I hopefully will be back tomorrow to answer all of your questions. And we will review tomorrow everything we've learned this week by video so that I can help you all. I'm also planning on having a study session Thursday after school as long as I feel up to it. And I will email all your parents about that. All right. I love you guys. I will see you soon. Behave yourselves. Don't get homework. And have a great afternoon. Bye.